So today we're going to take a break from augmented matrices, and we're just going to talk about normal matrices. So you're not going to see any of those dots in the matrices. Also, the matrices that we talk about today are not going to represent a system of equations. That really only happens when we have an augmented matrix, okay? So these are just normal matrices. They don't represent a system of equations, okay? They're just an array of numbers, okay? So first of all, if we have matrices that are equal, then that means their corresponding entries are equal. I think you have a blank that you can fill out. Okay, and I give you two matrices that are equal. Do you see how those 7s are in the same place and those 2s are in the same place? So if I wanted to figure out what x is, what would we have to do? Say that louder, Dallas. X plus 1 better equal 3. So what is x? Okay. Turn to the person sitting right next to you. Tell them what you think the value of y is. Callie, what's our value of the y? And how did you get 2? Excellent. Can you handle that? It's going to be the extent of our algebra today. Okay. All right, matrix addition. I know you did this in algebra 2. Okay. On your sheet, matrices can be added if. What is that if? What has to be true about A and B? Very good. Okay. Matrices can be added if they have the same order. Okay. If they don't have the same order, that's your next blank. The sum of matrices with different orders we call undefined. So if I ask you to add 2 matrices or subtract 2 matrices and they do not have the same order, you would write undefined. You can't do it, okay? Now, if I wanted to add 2 matrices because they had the same order, what's the process going to look like? It's like you knew what I was going to write. Okay. We're going to be adding corresponding entries. It's beautifully said. Okay. So the first row entries are going to be added with the first row entries. Second row entries added with the second row entries. Okay. So on and so forth. Okay. Subtraction is going to be similar. I mean, subtracting is kind of like adding the negative value. Okay. So subtraction, we're going to cover the same rules. But then there's one more basic operation. We are going to talk about matrix multiplication here soon. But first I want to talk about multiplying by a scalar. Okay, so do you see this right here? How I have this little c and this big A? Capital letters are what we call our matrices. You kind of notice that in our calculator. So this lowercase c represents like a number, like a constant. C for constant. Okay, so you can multiply a matrix by a scalar by multiplying each entry of the matrix by the scalar. So if you have a number multiplied out in front, essentially you distribute it to every single entry. So down below that box, you have these two matrices, right? A and B. What's the order of A? What's the order of B? So yay, they are the same. And since they're the same, we can add them together. Okay? So if we want to add A and B together, we're going to do so by adding corresponding entries. So let's focus one row at a time. So our first entry, we have 2 plus 2. Our next entry, we have 2 plus 0. And our third entry, 4 plus 0. Okay, now we can move to the second row. Some of you may have already done this ahead of me. Okay, we have -3 plus 1. 0 plus -4, -1 plus. Yep. You see how easy it is to make a mistake, though? Okay, so be careful, even though this isn't taking a lot of brain power. Okay, 2 plus -1, 1 plus 3, and 2 plus 2. On the non-calculator portion of your test, you can guarantee I'm going to ask you a question where you add matrices together. Okay. Hopefully that's like a gift of points. Right? Let's go to the next one. -2b. Okay, describe to me what we need to do. Multiply each entry by -2. So -2 times b, it's still going to be a 3 by 3 matrix. I'm going to take each entry, multiply it by -2. So we have -4, 0, 0, -2, 8, -6, 2, -6, -4. What I'm going to let you do, because some of you have already started, I'm going to let you do the last one together at your table. My suggestion would be to focus on 3A first, and then with 3A, subtract the matrix B. I'm going to go ahead and give you 1 minute to do that together with your calculator. Find 3A and then subtract B. Kinley, can you read me your 3A?
Yeah. 6, 12, -9, 0, -3, 6, 3, 6.
And then we're going to subtract matrix B to get at the end, what was your result?
4, 6, 12, negative 10, 4, negative 6, 7, 0, 4.
Do you agree with that? Okay. First part of your assignment is going to be questions like that. Okay. Adding, subtracting, multiplying by scalar. If you don't have the same order, that sum is going to be undefined. Okay? All right, so let's go to multiplication. This one takes a little bit more effort. Maybe that's how I'll describe it. Okay? So first of all, we can multiply matrices if A is m by n and B is n by p. Okay, so notice how those n's are the same. And if that's the case, then A times B is going to have m by p order. Okay, so let's really break that down. Essentially what needs to happen is that the number of columns of the first matrix needs to match the number of rows of the second matrix. Okay, so those middle numbers need to match up when you're writing the orders next to each other. Okay, and when we look at our result, m by p is our result. Okay. So what I'm probably going to ask you to do, I'm going to ask you to identify the order of A. I'm going to ask you to identify the order of B. Those two need to match up, and then what's left on the outside is your new order. Okay. When we multiply matrices, we do that by row by column multiplication. That's what I want you to fill in there. And then we're going to read that paragraph together. Matrix multiplication is row by column multiplication, where the ith row and the jth column of the product of AB, I know, is obtained by multiplying the entries of the ith row in A and the jth column in B and adding the results. Okay, so right now you're like, I just want it in words in case you have to refer back to it. But essentially we're going to take row times column, row times column, row times column. And you're going to have some products when you take row times column, and all those products need to be added together. Okay? So let's go through that example. And I do want you to write down what I have up here so you can refer to it this weekend when you're doing your homework. Okay? So first of all, what is the order of this A matrix right here? This is a 3 by 2 matrix. And this matrix right here is a 2 by 2. So these match up. And our product is going to be a 3 by 2. Now I want you to make that matrix really big because we're going to write a lot in it. We're going to write all of this in it right here. Okay? So make it a little wider than you normally would. Okay? So you remember how I said we're going to do the row times column multiplication? Let's go a row at a time. So we're going to take the row in the first matrix times the first column in the second matrix. So we're going to match these up. -1 gets multiplied to -3. 3 gets multiplied to -4, and you add them together. And that's your first entry. going to take the first row times the second column for our second entry. First number times first number plus second number times second number. See where that's coming from? -1 times 2, those are the first entries, plus 3 times 1, those are the next entries. We have now run out of columns. Do you agree? Okay. So we are going to start with the second row. And since now I'm going to multiply the second row, we're going to move to the second row in our product. Okay, so we're going to take the second row and multiply it by the first column for our first entry in the second row. Okay, so we're going to take 4 times -3 and add it to -2 times -4. The first numbers get multiplied together, the second entries get multiplied together. Then we'll move to the second row, second column. And that is a new entry. So we have 4 times 2 plus -2 times 1. First entry times first entry plus next entry times next entry. Now I'm making you write all of this down, but this is probably not the work that you are going to show me. Okay. Like for this next step that we take, when we take our third row times our first column to begin our third row, okay, do you see how the row that I'm choosing and the column that I'm choosing corresponds to where it goes in our product? Okay. Probably the work that I would expect to see would be you taking 5 times -3 and writing -15, plus 0 times -4, you would write 0. Okay? But for right now, just so you have your notes to look back on, I want you to write it all like this. Okay? And then taking that third row times the second column. Okay, so once you've done all of that, you can take the products and add them together for each entry. So here we have 3 plus -12 to get -9. -2 plus 3 to get 1, etc., etc. Thumbs up, thumbs middle, thumbs down. You remember this from Algebra 2. Okay. It's okay if it's rusty, but that's not a problem. That just means we need to practice. Okay? So you have 2 matrices written down below. You have A and B. We are going to find the product. So first of all, can we find the product? What is the order of A? What is the order of B? So what's our answer? Can we take the product? Okay. The 3's match up, so that's good. What would our product have an order of? She says with enthusiasm. AB is going to have an order of 2 by 2 because that's what's left over on the outside. Okay. So let's do it. Okay, so we are going to have a 2 by 2 matrix. So we should have 4 entries. Do you agree? Okay, so what we're going to do, we're going to take the first row times the first column, and we have 3 products to take. So this is the work that I would expect to see. I need to see you write down 1 times negative 2 plus 0 times 1 plus 3 times negative 1. I would suggest writing this instead of trying to do it in your head, because if you make a mistake, we can at least figure out which multiplication you messed up, or are you doing something completely out of context, okay? Like if you just mismultiply 1 times 0, we could find that. You see what I mean? Okay. First row times second column is going to go in the first row, second column. Okay, we have 1 times 4 plus 0 times 0 plus 3 times 1. Okay, I've run out of columns, which means we can move to the next row. Okay, if we take our second row times our first column, that's where we put the numbers. Okay, second row, first column. We have 2 times negative 2 plus negative 1 times 1 plus negative 2 times negative 1. And last but not least, second row, second column, we have 2 times 4 plus negative 1 times 0, negative 2 times 1. So our 2 by 2 matrix is negative 5, 7, negative 3, 6. Question I want you to talk about with your pod. Is matrix multiplication commutative? All right, who votes yes? Matrix multiplication is commutative. Who votes no? Matrix multiplication is not commutative. Hey, Brayden, tell me why.
Because, like, if you switch the order, then you're going to have different M P's, so the whole matrix will be different.
Okay, so in this case, if we took B times A, B was a 2 by 3 matrix, right? And A was a 3 by, oh, wait.
The other way.
B was a 3 by 2. Sorry, I can't see it anymore. And A was a 2 by 3.
Yeah.
So we would get a 3 by 3 matrix. That would be one counter example. Are you always going to be able to take the product of B times A? Okay? If you had A times B, where A was a 2 by 3 and B was a 3 by 1 matrix, you couldn't even take the product B times A because the orders wouldn't match up the right way. Okay. Now, in the case where you have a square matrix times a square matrix, like a 2 by 2 and a 2 by 2, A times B and B times A would have the same order, but you're not going to get the same numbers because you're multiplying different entries together. Okay? So no matter what, it's not going to be commutative. All right, that's all we have to do today. Well, for notes. Right. Okay, so go ahead and get out your homework. Place that note sheet wherever you need it.